Allocation problems. Okay, here we have bipartite graph. One graph where there's two separate sets of vertices. In this case we have the positions and we have the
applicants
for
a job. So
right.
It looks like here applicant 1 can apply for position 2 and 3.
Applicant 2 for position 4, applicant 3 for position 4, and applicant 4 for 1 and 5. Of course, we can't fulfill this because we've got one more position than we have applicants.
So in order to work something out here, we use something called the
Hungarian algorithm.
Right.
So let's do an example with it. Here we've got 4 supermarkets, A, B, C and D, which are supplied by 4 distributors, and we call them W, X, Y and Z. Of course, these are only letters. We can change the letters as we like. The cost of supplying 1 van load of goods is given in the cost matrix.
So this one here looks like that distributor W can supply to supermarket A for $30.
Yep, for 1 van.
For 1 van, or $40 for supermarket B, so on and so forth.
Yep. And you know, the aim is to supply each supermarket at the lowest cost. And we do this using this algorithm, the Hungarian algorithm, to determine the minimum cost. Right, we're going to write these in steps so you can easily follow. Step 1A says find the lowest entry in each row and subtract it from each entry in that row. So if we look at the row W, because remember this is row, so row W, 30, 40, 50 and 60, 30 is the lowest number. We're just going to circle that. In row X, again we look at it all, 30 is the lowest number again. In row Y, again that's 30, and in row Z it's 20. So from each row we have to subtract their normal ones. And from row 1, 30, row 2 was 30, row 3 was 30, and row 4 was 20. Now, we had 30 at the start, so 30 take away 30 gives us 0. 40 was in the next one, 40 take away 30 gives us 10, and so on. I'm just going to read out the numbers, 20 and 30.
So we've got to do this for every row,
yep.
Subtracting it from the lowest score.
Row 2, we're subtracting 30. So we've got 70 in the first one, 70 take away 30 gives us 40 left over. In B we had 30, take away 30 gives us 0, and now we've got 10 left in this one and 40 left in this one. We're doing 30 from row 3, I'm just going to read out the numbers, 30, 20, 30 and 0, and in row 4 we need to take away 20, so it's 0, 60, 30 and 50 once we take away the 20. Now what we do for step 1B, we repeat the process for the columns where there is no 0 entry. No 0 entry. So let's have a look at all the columns. Column A, yeah, there's 0 there. Column B, there is a 0 there. Column C, there is no 0 in here. So what we do is we again pick the lowest one, which happens to be 10. And column D, there is a 0. So we only need to worry about column C. So now for this column C, we've got to take away 10. So all the numbers, I'll leave column C, I'll read column A, column B and column D, and then we'll do column C. So column A was 0, 40, 30 and 0. Column B was 10, 0, 20 and 60. Column D, 30, 40, 0 and 50. Column C, we have to take away 10. So we end up getting 10, 0, 20 and 20. Okay. Step 2. We cover the 0 elements. So all the 0 numbers with the minimum number of lines. If this minimum number of lines equals the number of rows, then you can draw a bipartite graph. If not, you have to continue. And you have to find the smallest element. Alright, but let's get to this. Let's continue. So let's try and draw lines through this one. We'll draw one straight down A, straight down D, and across X. And we have covered all the zeros.
So you've got to cover all your zeros in the least number of lines.
I mean, you could have done A, B, C and D, but then that gives you 4 lines. We can do it in 3 lines, so you've got to do it in 3. Now we've got 3 lines, but we've got 4 rows. So we need to continue. So step 3. says find the smallest element without the line through it. So if we go back, the smallest element without the line through it is element number 10. All right, number 10. And what we do, we add this to the rows and columns that are covered. Add this to the rows and columns that are covered. So we're going to do it to here. So we had covered all of A. So we go 10 for A. Leave the X for the moment. Let's go to the Y, 30, and 0 for the Z. The reason I left the X is because it has a line as a column and also a line down A, and it also has a line going across the X. So it has two lines. So we have to add 10 for the one coming down, the line coming down, and 10 for the line coming across. For that part, we have to add 20. So we get to 40 there. Sorry, 60. Sorry, 60. Oh, and Z is 10 and 40 for the Y. We made a mistake there. 40 for the Y.
I'll just do that again.
There's 60 there, 40 for the Y, and 10 for the Z. Now B, this is what B is, 10. We have to only add 10 in this section, so we get 10, 20 here and 60 here. 20 and 60. We don't add anything to those ones. 10, nothing's added. We've got to add 10 to this one, so it makes it 10. 20 stays as 20, and the next 20 stays as 20. The next one we have to add 10, so it becomes 40. The next one we have to add 20, because remember we had a line going down column D and a line going across for X, so we add, becomes 60 now. Add 10 to this one becomes 10, and add 10 to this one, it becomes 60. And now the next part says we need to subtract this 10, because that's what we added, 10, subtract 10 from all the entries, from every single entry. So we end up getting this one when we subtract 10. 0. 0. Oh, sorry, I thought you were going across, sir.
That's okay.
0 and 30. And then for the next row, 50. 0, 0 and 50. 30, 10, 10 and 0, and 0, 50, 10 and 50.
Because you're just taking 10 away from each element.
That's right. And it says to repeat step 2. Now step 2, remember, cover the zeros with the minimum number of lines. Now it doesn't matter which way we do this, we can only get 4 lines covering. So we can do it this way, and 2, 3 and 4. And because the number of rows equals the number of lines, then we can draw a bipartite graph. And this is how we draw it. For the W, we can go to where the zeros are. So W goes to A, and we'll draw a line from W to A, and we'll put the arrow on there. W can go to B, and we'll put the line on there. And it's just easier to see with the bipartite graph as well. And W can go to C. Then X can go to either B or C. And Y can go to D only. And Z can go to A only. So here we have 2 choices. Alright, so we'll put 2 tables here. We'll do a cost for both of them because there's 2 choices. We'll leave some space because W can go to a couple of places and so can X. So we'll just put W and leave that one for now. We'll put X2 and we'll leave that one. And Y can only go to D. So we'll have to write that in. Y can only go to D, and that is a total of 30. And we get that 30 from the original graph, from the original table that was given us. Y to D is 30. And Z can only go to A. Z can only go to A. Z to A. And that is 20, which leaves us with B or C. Now B or C, W can go to B or W can go to C, and X can go to B and X can go to C. That's why we have the 2 choices. So we'll have W going to C, to B. We might as well leave that one to B, and we'll have the X going to C here. X going to C here. Now W to B is a cost of 40 and X to C is a cost of 40. A total that we get for these ones is 130. The other side will do the same thing. Okay, W this time will make go to C, which is 50. X to B, so we've just swapped these two around, which is 30. Y still has to go to D, there is no choice. We can see that clearly from the bipartite, which is 30, and Z to A, which is 20. And that still has to go to A, we've got no choice there, and that still gives us a total of 130. So it doesn't matter which way we go those ones, we're still going to get the same total. Okay, and so exercise 24D. There are more examples in your book. You're quite welcome to have a look at those.